class 8. So last time we did separation of solid liquid mixtures. So what were the methods we used for separating solid liquid mixtures? They were sedimentation, decantation, then filtration, then evaporation, then crystallization, then another was centrifugation, then distillation. These were the methods of separating solid from solid liquid mixtures. Solid from solid liquid mixtures. Today we will be doing separation of liquid mixtures. Separation of liquid mixtures. So we will go in detail regarding this separation of liquid mixtures. So liquid, that means one component is liquid and another is liquid. Another is also liquid. Now if I say salt water is an example of liquid mixture, will it be right or wrong? It will be wrong, because salt and water, salt is solid, so it has to be solid liquid mixture. It has to be solid liquid mixture. But if I say kerosene oil in water, then kerosene oil is liquid, water is also liquid, so it will form liquid mixture. Liquid mixture. But whenever you mix kerosene oil in water, can you see it mixing thoroughly? Can you see it mixing homogeneously, uniformly? Can you see it mixing uniformly or spreading or mixing this one? Can you see the distribution, the spread is throughout the bulb? No. It forms different layer. So let's see. Now whenever this forms different layer, they are called, these type of liquids are called immiscible liquids. See here. It is a wise, that means this kind of liquids forming different layers can be separated by using separating funnel. So it is a simple device. What is the simple device? It is separating funnel. This apparatus is a separating funnel. So separating funnel is a simple device used to separate the components of a liquid immiscible mixture. I said immiscible. Immiscible means immiscible liquids are those liquids which do not mix uniformly, which forms different layers. Those liquids on mixing forms different layers are called immiscible liquids. Immiscible liquids are those liquids which form different layers on mixing. So these type of liquids can be separated by using separating funnel, in which liquids have different densities. So one liquid will be going up, going down, and one comes up and forms different layer. So they have different densities, that's why one is going down and the other is coming up. Example, the mixture of kerosene oil and water is placed in a separating funnel and allowed to stand for some time. The components form two clear layers. Water being heavier forms the lower layer, and kerosene oil being lighter forms the upper layer. So that here you can see this lower layer, this is water, because water is heavier than kerosene oil. So water lies down, and this is kerosene oil, which is lighter than water, goes up. So upper layer means lighter component will go up. Lower layer means heavier component. Okay, upper layer, which will occupy upper layer? Lower component, lighter component. Okay, upper layer, lighter component, lower layer, heavier component. And in this case of mixture of water and kerosene oil, water is heavier, it comes down, and kerosene oil is lighter, it goes up. So when the stopper of the funnel is opened, here is the stopper. Here's the stopper. First of all, you will put the mixture through this. Using for another funnel also you can do, so that the drops may not splash out, may not come down, may not get splash out, or it goes other way. So you can take a funnel also, so that all the mixture goes into this separating funnel. And then this is the stopper. You can just leave it for a while until, as soon as you put the mixture, don't open this stopper, otherwise you cannot separate the mixture. So you just stand it for a while, you just keep it for a while. So what do? You just stand for some time, then they will form different layer, and once you can see the different layers formed, you can slowly open this stopper. Then the lower layer liquid will start coming down and it will get collected here. This is heavier liquid. What will get here? Heavier liquid. That means lower layer will come here. So then whenever you will come to this portion, then drop by drop you have to put. Drop by drop you have to allow the lower layer, the heavier liquid, to fall down. Then as soon as this lower layer, this heavier liquid is finished, you can again stop the stopper and kerosene oil will be left here, water is separated. So in this way, kerosene oil and water or all the immiscible liquids can be separated by using separating funnel. Now, the heavier liquid trickles out slowly and is collected in a vessel. The stopper is closed when the lower layer is entirely removed from the funnel. In this way, the two liquids, kerosene and water, are separated. Mixture of carbon tetrachloride and water also can be separated by this method, in which water forms the outer layer. So if you take the mixture of carbon tetrachloride and water, then carbon tetrachloride is heavier than water. So carbon tetrachloride will form lower layer and water will form upper layer in this case. So this is the way how we separate immiscible liquids using separating funnel. My dear students, hope you have to make this, you have to draw this figure in your copy. This with this level diagram. Okay? Level diagram, figure 3.9 you have to draw in your copy. Then number one was by separating funnel, by using separating funnel for the immiscible liquids. Now this one, fractional distillation, this is for miscible liquids. So what are miscible liquids again? Homogeneous mixture of liquid. Homogeneous mixture of liquid substance is called miscible mixture. Miscible mixture, that means here one liquid mixes with another liquid uniformly. They form homogeneous mixture. So this process of distillation, this is also distillation. Fractional means partly, okay, step by step. This is also distillation. What is distillation? Distillation is the process in which first of all the liquid gets evaporated and it condenses. So the same process, the same method is used here in this case also, but fractional, part by part it will be. This distillation takes place part by part, step by step. So that's why it is called fractional distillation. This process of distillation is used for separating the liquid homogeneous or miscible mixtures in which the liquids have different boiling points. Now, in case of separating funnel, in order to separate the liquid mixture from using separating funnel, what must be there? The liquids should have different densities. In order to use fractional distillation, what is the condition? The liquids have different boiling points. The liquids must have different boiling points. On heating the mixture in a distilling flask, the liquid with the lower boiling point converts into vapor first. So, on heating the mixture in a distilling flask, so this is your fractionating column. This is your fractionating column. The mixture is here. The mixture is added here in this. Then what happens is, the liquid with the lower boiling point. The liquid with the lower boiling point boils first. The liquid with lower boiling point boils fast. it will boil first, and then vapor will be formed. So when this process is going on, until and unless all the liquids having this lower boiling point is converted to vapor, okay, the converts into vapor first and then gets condensed and collected in the temperature remains stationary. The temperature remains stationary until and unless whole of the liquid with the lower boiling point boils. Then only after this, again another liquid with boiling point little more than this will start boiling. That means it starts converting into vapor. Then again when it is converting into vapor, the temperature of the mixture remains fixed. When it is over, when all the liquids of the second type vaporize, then only the temperature rises and another liquid mixture starts, liquid component starts boiling. So this way, this fractionating column or this fractional distillation takes place. So the temperature remains until whole of that liquid distills over. The heating is now continued, the temperature rises and the second liquid starts vaporizing. At its boiling point, the vapors then get condensed and collected in another receiver. So first of all, the liquid with lower boiling point will vaporize, then that will condense, then that is collected. Say for example, this is collected in another container, this is collected in another container. So what you can see here, this petrol boils at 40 degrees Celsius to 70 degrees Celsius. That means which is collected first from petroleum, crude petroleum. From crude petroleum, first of all petrol is collected. Why? Because its boiling point is 40 to 70. So when petrol from petroleum is boiling, is converting into vapor, the temperature of the petroleum remains same, it will not change. Then when whole of this petrol is converted to vapor, condensed and then collected in one container, then only this naphthalene starts boiling, converting into vapor. Then naphthalene is collected. Then kerosene from the mixture starts converting to vapor. Then kerosene is collected. Then comes gas oil or diesel. Then fuel oil because its temperature is 360 to 400. Then lubricating oil. And last hot oil vapor. So last is bitumen. The big molecules with high boiling point. So bitumen is big molecules with high boiling point. So which is the last component that can be separated from crude petroleum oil? That is bitumen. Why? Because its boiling point is high. And why petrol? Which is the component that is first collected from crude petroleum oil through fractional distillation? Petrol. Why? Because its temperature, its boiling point is very, very, very less. That is 40 to 70. Within 40 to 70 degrees Celsius, whole of the petrol from the petroleum oil is separated. So that's why this is called fractionating column and the process is called fractional distillation, because all the components which is mixed uniformly, homogeneous mixture. By looking at crude petroleum oil, you cannot say this is petrol, this is diesel, this is naphthalene. You cannot say. But once the mixture is added, once the mixture is heated in this fractionating column, you will get different components at different temperature. So temperature difference is must. Temperature difference is must. So complete separation is possible only with the difference. Now, when is this fractional distillation 100% successful? When the temperature difference, boiling point difference between two components is more than 30 degrees Celsius. Okay? If the difference is less than 30 degrees Celsius or fractionating, okay. So if it is more than 30 degrees Celsius, you can use distillation also. But if it is less than 30 degrees Celsius, then you can use fractional distillation. So one condition is they should have different boiling points. Another condition is they should have boiling point less than 30 degrees Celsius. They should have boiling point less than 30 degrees Celsius. The difference between the boiling points should be less than 30 degrees Celsius. These processes called fractional distillation. Water and alcohol are separated by this method. Boiling point of alcohol is 78 degrees Celsius and that of water is 100. So what is the difference between the boiling point of water and alcohol? It is only 22 degrees Celsius. So by using distillation also we can separate, but will not get 100% pure alcohol. But by using fractional distillation we can get 100% pure alcohol, because 95.5% pure alcohol is obtained by this method. So petrol, kerosene, diesel, etc. are obtained from crude petroleum oil in a similar way. Now, if there is anything lighter than petrol, then that comes out first. See here, petroleum gases, that means LPG, has lower boiling point, that is below 40 degrees. So, I'm sorry, I said first of all it is petrol. No. First of all it is gases, natural gases. Petroleum gases, methane, propane, ethane, butane. All these small molecules with low boiling points. This will be separated first, then petrol, then thermine, then kerosene, then gas oil, then fuel oil, then lubricating oil, then hot oil, vapor, then bitumen. So this is the way how components from this one, crude petroleum oil, is separated. So first to get separated is petroleum gases. Okay. So this figure also you will draw in your copy. Then fractional distillation is a process which involves distillation and collection of fractions of different liquids which are boiling at different temperatures. So what is fractional distillation? It is a process which involves distillation. It is a process which involves distillation. The procedure is same with that of distillation, but collection of fractions of different liquids. But the different liquids are collected at different temperatures. Because they boil at different temperatures. Homogeneous liquids, liquid mixtures are called miscible liquids. Liquids which dissolve in each other completely in all proportions are called miscible liquids. Example, alcohol is miscible with water. Mixture of alcohol and water, they do not form different layers. They mix thoroughly, homogeneously. Liquids which do not dissolve in each other are called immiscible liquids. Liquids which do not dissolve in each other are called immiscible liquids. They are heterogeneous liquid mixtures. So heterogeneous liquid mixtures are called immiscible liquids. This can be separated by using separating formula. And homogeneous liquid mixtures are called miscible liquids. They are separated by using fractional distillation. Okay. Then chromatography. The word chroma means color. Graphy. So this method uses color. This is one of the latest techniques to separate the components of a mixture when all the components are very similar in their properties. When all the components of the mixtures are very similar, then chromatography can be used. This separates the mixtures on the basis of their different colors. So chromatography is also used for homogeneous liquid mixtures. So example, components of ink are separated by this method. Ink is a mixture of different dyes. Dye means color imparting substances. Color, dye you can say color. Okay, so components of ink. When you see ink, you say blue ink or black ink. But this blue ink contains a lot of colors. A lot of colors are there in this blue ink or black ink or red ink. They are made up of different coloring substances, dyes. which are separated by chromatography because some of the dyes are less soluble and some are more soluble in a solvent. So, on which principle chromatography works? This works on the principle that all the components in a particular substance, a particular mixture, do not get soluble in the same solvent. So soluble and some are more soluble. So some are less soluble, some are more soluble in a given solvent. The name chromatography means color lighting. Color lighting. It is named so because earlier it was used to separate mixtures containing colored components only. But now this technique is applied to colorless substances as well. Now, previously, in the olden days, this process, chromatography, was used to separate colored components from the mixture. But nowadays we can use this for colorless substances also. Okay, the process of separating different dissolved constituents of a mixture by their adsorption on an appropriate material is called chromatography. So, chromatography is the process of separating different components of the mixture by their adsorption on an appropriate material. How they get adsorbed on a particular material, on the basis of that, different substances are separated from the mixture. This method is based on the differences in the rates of adsorption. So, all the substances, all the components present in the mixture may not have the same rate of adsorption, same rate of absorbed, okay, same rate of adsorption. They have different on the surface of a suitable adsorbent. So what is adsorbent? The substance in which the substance get attached is adsorbent, and the substance and the process is called adsorption. Common adsorbents used are filter paper, silica gel, etc. So, which are the common adsorbents? The material in which the component get attached. So, which are the common adsorbents used? They are filter paper, silica gel, etc. Common solvents used are water, ethyl alcohol, acetic acid, etc. So, solvent. These are adsorbents and these are solvents used are water, ethyl alcohol, acetic acid, etc. Principle involved in chromatography. So, on which principle does chromatography works? On which principle does chromatography works? So, chromatography separates the components of a mixture on the basis of differences between two phases, one of which is stationary while the other is mobile. It depends on the basis of difference between two phases. One of the phases is stationary, means one remains at rest, one is the mobile phase. One is stationary, rest. The phase one remains at rest, one moves on that rest phase. Rest substance, stationary substance. The simplest type of chromatography is paper chromatography. The simplest type of chromatography is paper chromatography, and regarding the detail of how this works will not do. Okay, you will do in higher classes. So now today we'll see about the applications and advantages of chromatography. So advantages: a very small quantity of the substance can be separated. Even a trace amount of substance also can be separated by using chromatography. Components with very similar physical and chemical properties can be separated. Now, components having very similar physical and chemical properties also can be separated by using chromatography. It identifies the different constraints of a mixture. What are the different constituents present in a mixture can be easily identified by using the process called chromatography. It also helps in quantitative estimation of components of mixture. How much of the particular component is present in the mixture can also be estimated by using chromatography. Then what are the applications of chromatography? Chromatography can be used to separate colors in a dye. So what are the colors present in a particular color imparting substance? Drops from blood. So nowadays drops, okay, generally when accident and all takes place, then they send for blood test. So in the blood what they find drops, and in order to find drops from the blood, which process is used? Chromatography. Then pigments from natural colors. Pigments from natural colors. For example, chlorophyll is a pigment. So pigments are separated from natural colors by using chromatography. Number 2, to purify many industrial products. To purify many industrial products also chromatography is used. Okay, this much for today, and I hope you will do the work associated with this video. Thank you.